Hi all. Recently, Chroma raised $18 million at a valuation of $75 million. Pinecone raised $100 million. Pinecone started in 2021. But why are we talking about Chroma, Pinecone files? Well, remember, with the advent of generative AI, we are dealing with a lot of unstructured data such as text, audio, video. These unstructured data are very high dimensional data, and in order to efficiently manage, store, and retrieve these high dimensional data, we talk about a special database. Yes, we are talking here about vector databases. Pinecone, Chroma, Faiz, all these offer vector databases, and if you have been following my LangChain tutorials, you would have seen that we have already worked with ChromaDB, which is one of the vector databases. So in this particular video, we are going to talk about what are vector databases, and secondly, why should you care about vector databases. Additionally, we shall see how vector databases are different from relational databases. So first of all, understand what are vectors. So if you understand from your mathematical annotation, vectors are arrays of numbers, right? Vectors are arrays of numbers that have a magnitude as well as direction. They represent a data point in n-dimensional space wherein the data points that are similar to each other occur in a cluster or a group together. So this is the underlying objective of using vector databases. Vector databases store high dimensional data primarily in the form of a vector such that the similar data points or the similar data are grouped together or occur in a cluster, right? You understand vectors very simply. Now, why are we talking about vector databases? Now, we said like generative AI deals with unstructured data. Now, in order to store these unstructured data, these high dimensional data, uh, consider this analogy. Imagine finding a needle in a haystack. Is it a simple task? No, absolutely not. It is a very tedious task. Now, what if all the needles that are available in the haystack are grouped together? Now the task becomes much more simpler, isn't it? This is what we are talking about in vector databases. We are trying to group together the sparse data or the data that is kind of a needle in a haystack together. We are grouping them together such that the information retrieval becomes faster and we are able to generate information quite easily, right? This is the primary advantage of vector databases. Another reason is that AI applications involving LLM rely heavily on vector embeddings for storing and processing high dimensional data. They require efficient storing, querying high dimensional data that is faster and efficient. Vector databases enable fast and efficient storage for these high dimensional vector embeddings, and therefore the need for vector databases. Some of the popular vector databases include ChromaDB, Pinecone, Fize, VV8, etc. We have already worked with ChromaDB when we talked about our LangChain tutorials. You can go ahead and check them out. Additionally, I'll attach some links in the description. Make sure to check them and understand how these different vector databases relate to each other and how they operate. Now, coming to the primary difference between vector databases and a traditional relational databases. Traditional relational databases were optimized for exact matches. You need to look for a particular record, you go ahead and fetch that record directly. Vector databases, on the other hand, are optimized for similarity searches. The reason being, when we go for these generative AI models, the results are not very deterministic. What we are looking for is the answers that are relevant to our questions or to our queries or to our prompts, right? This relevance is determined based on the similarity factor that these vector databases maintain. Now, when you pass a particular query, the information is fetched from the vector store or from the vector database, and the most relevant information is passed on efficiently and quickly, thus making LLMs process data efficiently. I hope this makes sense to you and you learned something new. See you in the next lecture. Have a nice day. Bye bye. Jai Hind. If you like the lecture, don't forget to give it a thumbs up.